Hi to everybody. Indeed, it is really time now to show you how much all this data gathered throughout futurevolc and all this good research done within this project has been, at a certain point, translated into operation. So that's why Matthew and we are going to show you how much futurevolc really contributed in creating a state-of-the-art monitoring system at the IMO. IMO is the Icelandic Meteorological Office, and despite its name, indeed the IMO is the institution in Iceland that is responsible to monitor all the natural hazards and hazardous phenomena occurring in Iceland, and issuing warnings and alerts, and whenever possible, even forecasting these phenomena. Of course, I mean, this talk is a contribution of Matthew, and Kristín Jónsdóttir, and a wide group of collaborators from the IMO. So very briefly, I will go through the importance of monitoring volcanoes, which have been all the events that fortunately we have had the opportunity to monitor during the futurevolc duration. The role of futurevolc in advancing monitoring, and then particularly we will focus on 3 case studies. So as you see, I will just cover the first one. Matthew then will take care of the second, the third one, and then he will give you the overview of the monitoring legacy of futurevolc. The next one. So why it is important to monitor volcanoes? Well, we have seen so many hazards, volcanic hazards, can be associated with a volcanic eruption in Iceland, all over the world, indeed. We have decided to show this plot that somehow is showing us how we can build, all the elements that we need to build a proper volcano risk system. So, and it is nice to see how much futurevolc somehow is, percolating through this diagram. So we are moving through improving monitoring network to study the eruptive products, eruptive processes, what happened in the past, so what we know from the volcanoes. And of course, moving through this plot, IMO start to get all the responsibilities of communicating hazards and issuing warnings, and somehow then to bridge this gap to our stakeholders, indeed with the civil protection in Iceland. So of course, monitoring observation constitute the only scientifically valid basis for short-term eruption forecast whenever possible, but of course then the elements for a proper risk reduction are then of course hazard assessment, effective communication among scientists, civil authorities, and the general public. Next one. So if we want to stress once more the main goals of futurevolc, we should at least report development of new methods to evaluate volcanic crises through an increase in the scientific understanding of the magmatic processes, with the improvement on how we can really deliver the relevant information to the important stakeholders. How these goals translate to our goals at IMO, indeed, we should just simply say, how we can really use futurevolc to improve our ability to issue accurate, in time and space, early warnings for impending natural hazards, particularly volcanic hazards, and at the same time being able to establish and develop an efficient communication protocols. So as I was saying, indeed we have been quite lucky, because if we look at this timeline, we can see how many events we have been able somehow to monitor or look at throughout the duration of the project. So we started in 2013. We had a hydrothermal explosion in Kverkfjall. We had an ash resuspension event that has mainly affected the southern part of Iceland. We had a flood that occurred under Mýrdalsjökull. We had the landslide that Maurizio referred to this morning at the Askja volcano. We had, of course, the Bardarbunga crisis and the Holyroyn eruption, and then just very recently, the Skaftárhlaup that happened just last month. Just to give you an overview of where these events happened in Iceland, here are also kind of reference letters. So of course, Holyroyn here we are focusing on Bardarbunga. Holyroyn indeed happened here. We had Askja, where we had the landslide, Kverkfjall, then the Skaftárhlaup that indeed happened in this area, and then of course went towards the sea, the Sólheimajökull, flood, as well as the resuspension event that really has been quite effective in this, in the town of Vik. So I think it is important just to show you how much all the instrumentation that was supposed to be working within futurevolc has been really able to be used, and somehow, most importantly, IMO has been really able to get the data almost in real time. So I'm going just to show you a couple of slides where I'm really go through a kind of list of instrumentation where you can even see, which has been then the main collaborators in order to manage and operate this instrumentation for both the atmospheric as well as the geophysical monitoring. So indeed, if you look at this at this table, you can see how indeed we have been quite good in being able in create a link. Most of the time we had to deploy the instrumentation into the field. Quite often it is a very hard, harsh environmental condition. So we have been able to test, and you can even see here for which event we have been able to validate or really test or verify the use of its instrumentation. We are still, indeed, futurevolc is still not over, so we still have some time to still, improve something, and indeed, we have definitely to test some of those instrumentation. In particularly, as we were already mentioning, this ash sizer that will be so valuable in case of an ash-rich eruption, and of course it will be as well so valuable that IMO will be collecting or receiving the information almost in real time from this instrumentation. If we move to the geophysical monitoring, the situation is even definitely better, because almost all the instrumentation that have been deployed or that was planned to be in place throughout the duration of the project has been really checked and already well used throughout all these events that I showed you. Except, of course, for these two samplings related with the gas monitoring, that for which it was not planned a streaming, a transfer of data in real time to IMO just because they are supposed to happen through campaign. So, one of the main roles of futurevolc was the idea of increment the type and number of installations installed in the country. And this is what we have just seen, but of course, together with that, we worked hardly in order to implement the way how to transfer data, as well as process the data, so new methods and new technique. As I said, somehow the IMO is playing as the integration hub. Most of the data are coming there, mostly the real-time data. So this kind of data integration is happening there in real time. We have in the monitoring room a 24 hours shift of our scientists that is taking care of looking at all the multi-parameter data that are just arriving in-house. futurevolc has really taken care of improving communication and practices. It is important here to say that IMO started to issue reports, a weekly report on the status of Icelandic volcanoes, and it is going to both national and international partners, as well as the use of the aviation color code map. And of course, as already mentioned nicely by Magnus, collaboration, collaboration, collaboration. So as I told you, we are going through three main cases. I will just cover the first one, the volcanic unrest. So we have already talked a lot about Bardarbunga. At the very beginning, when still the activity was beneath the ice, the expected scenario was, of course, an explosive eruption under the ice. So for which the two main hazards would have been floods and, of course, ash in the atmosphere. So the need at that time was, of course, to improve our capability in detecting changes in the seismicity, dike deformation, the caldera subsidence. So, of course, a huge effort in increasing the seismic network, GPS coverage, INSAR, satellite products, but as well as being ready with the radar in order to catch any signals from a potential ash cloud in the atmosphere has been used. We have seen this slide before this morning from Andy, and this is showing, the current situation of the continuous GPS installed northwest of Vatnajökull. But I think it is much more effective if compared with the situation at the very early stages of futurevolc. So the implementation of the network indeed has been really massive in the last 2 years. And I should say that throughout the Bardarbunga crisis, in addition to the GPS, 6 more seismometers, 1 accelerometer just within the caldera, and 1 infrasound arrays have been installed. Once the eruption started off, of course, as we said, a huge amount of gases started to be released from the eruptive fissure, and it is worth to mention that after 1 week, we have been able to install a DOAS to measure the SO2 flux. In total, 3 DOASes have been installed just around the lava field, a multigas to detect or measure gas ratios, and in total, more than 10 mobile DOASes have been done throughout the duration of the eruption. Why? The main reason, through this setup, we have been able to constrain the flux of the SO2 in total, and its total budget. We have been able to assess the amount of other volcanic gases released during the eruption. Most importantly, we have been able to initialize the source of our dispersal model for the SO2 dispersal at Icelandic level to provide information and forecasting to the people. And at the very end, when the eruption was over, this allowed us to still monitor the area once the public was allowed to access the area again.